Okay guys, so we're going to push on with chapter 10, which is operating fire pumps. All right, so how do we put the pump in operation? And this is going to be a nice review for most, if not all of you all. Okay, so putting the pump into operation obviously begins after we get our position. I know that Captain Britton talked about positioning apparatus in his class, so now we're moving on to that next step, getting the pump into operation. We get positioned, we get our parking brakes set, okay, and we can go ahead, and if we're going to be using the pumps, obviously, then we're going to be switching the pump shift from the drive transmission to pumps, okay, hop out, and always a good idea to chalk your wheels, okay, every time you get out of the cab. All right, so first thing we'll talk about is operating off the onboard tank. Again, as I said in the last chapter, you know, we can get water into our pumps from two ways, the booster tank or from an external source. Okay, so we're going to talk about operating from the water tank first. Usually not a problem, okay? You have it in pumps. Okay, your firefighter lays his line. Okay, you pull your tank to pump valve and supply that attack line. Okay, pretty simple. All right. Then you increase your throttle. Okay, you open your valve, you get that water on that line, increase your throttle and get up to the proper pressure. Okay, now we only operate one attack line off of a booster tank. Okay, we do not do any more. That's a rule that we follow here with Louisville. So you're not laying any more lines, or at least you're not operating any more lines until we get an external water source. Okay? So, once your job there is, you know, once you get the pump into operation, is to monitor all the gauges, everything on that pump panel. Okay, your discharge gauges, your intake gauge, once you get an external supply, and then obviously monitoring, you know, engine temperature, oil pressure, all those things that we talked about, all that instrumentation needs to be monitored by you, and that is your responsibility while the pumps are in operation. Okay, so what you'll find is, and you know this as a firefighter, you know, a lot of times, you know, our bread and butter fires, we have one room of fire, two rooms of fire. You'll go in, firefighter will go in, knock down the fire, and we'll have, you may potentially have another line. You know, if the fire gets a little bit bigger, you may have several lines, but they intermittently are being turned on and shut off, okay? And so you may or may not, at several points during the incident, not have any water moving through the pump at all. So you need to keep water moving to prevent overheating, okay? Overheating of the pump causes damage, okay? Our apparatus are not equipped with circulator, bypass, or booster cooling valves, okay? But we can cool the pump in several methods, okay? Again, we can operate the tank fill, okay? Just to circulate water between the tank and the pump, okay? And it keeps that water moving, keeps it cool. We can operate a drain valve if we need to, okay? But in the instance where we are just using our onboard water supply, we can use that tank fill and just keep circulating water through the pump. Okay, another thing that you can do, open a discharge or crack a discharge somewhere. Again, just moving a little bit of water. I talked about the drain valve already. Or if your apparatus is equipped with a booster line, pull that booster line and run it into the top of the tank fill on top of the apparatus. Open the booster line and your circulating water that way. Okay. In order to partially open the tank fill valve and not create the potential for pump cavitation, some driver operators open the valve to the distance of their thumb to the pump. In other words, you're just cracking it. Okay, you don't have to open it all the way. Okay, but just crack that tank fill line so we just continue to circulate water. Okay, now we will transition to an external water supply. Okay, and so part of your responsibility is to, get your supply line hooked into the appropriate pump intake. And if you don't hear anything else, hear me now. Make sure that you put that 5-inch supply line into a 5-inch intake and not into the 5-inch discharge that your apparatus may be equipped with. That has happened. Okay, make sure the line is in your intake. Okay, so take the time. You need to be fast, but you need to be efficient. Okay, make the connection to your intake with that closed gate valve. Okay, you open the bleeder on top of that gated intake. Okay, you get the hydrant going, you get water there to the intake. And what does that bleeder valve do? Okay, what it does is it lets all the air out of that intake hose. Okay, so that we don't introduce air into our pump and cause an interruption in water flow. So we open that bleeder valve, let the air push out, okay, and continue that operation until we get a steady stream of water through that bleeder valve. Then we can shut that down and then slowly open our intake. Okay. Now, we need to make sure that before we do this, that we also have our relief valve set, so that the pressure from the hydrant, the guys don't feel that on the end of their attack line. Okay, so once you get your intake open, now you're going to have water on your pump. You're going to be able to go around, potentially throttle down, okay, and use less engine RPMs, because now we're using pressure directly off of the hydrant itself. Okay, some considerations we need to take when we're operating from a pressurized supply source. Again, the two basic pressurized sources we may have be from a fire hydrant or from another pumper. Okay, with either of these sources, water enters the pump under pressure. Okay, so as I just said, okay, your discharge pressure is going to increase once that intake is opened. Again, either from a hydrant or from another pumper. All right. But let's say you have to start pumping more water, start discharging more water. Okay, then we could run into a problem. Pumping at low residual pressure while being supplied by other apparatus is dangerous. Okay. We need to maintain at least 20 psi on our intake gauge and don't go below that. If you were ordered to lay another line, you need to let that individual know, and it may be the incident commander, that, Mage, I'm at 20. Okay, I'm tapped out. Okay, we go below 20, we can cause some problems with our pump. Okay, we can collapse our supply line, or we can potentially collapse the water main if we're getting pressure, if we're getting water off of a hydrant. Okay, so the rule of thumb there is 20 psi. We don't go below that on our intake gauge. When you're choosing a hydrant, a couple things need to be taken into account. Obviously, safety, okay, and the needs of the attack itself. Okay, so the closest hydrant may not always be the appropriate hydrant. One reason for that is it's just too close to the fire itself. Okay, so we have to choose a hydrant that's further away in order not to put our apparatus in danger. Okay. To make an informed hydrant selection, thorough knowledge of the water supply system is necessary. Okay, so hydrants that are served by large, and this is firefighter 101 stuff, but hydrants served by large mains interconnected in a grid, okay, usually have better pressure. You have water coming from two different ways supplying that hydrant. Okay, they have less sedimentation, less deterioration. Okay, less desirable hydrants are typically located on dead-end mains. Now, a couple things about dead-end mains. Okay, if you know how much, if you have done some planning, and you may potentially know how much water you can get out of that hydrant. It's not necessarily a bad thing to take a dead-end hydrant. Okay, it's water. If it's there, it's available. It's right there. One thing I would really stress you do, and I know we don't do this on most of our hydrants, but if you know it's a dead-end hydrant, I would flush that hydrant prior to, or have your water guy flush that hydrant prior to hooking that supply line up. You don't want all that nasty sediment and debris flowing through your pump if you can help it. Okay, and then if you discover that you're not getting enough water out of that hydrant, you have some water, and then, you know, we have the luxury within the Louisville Fire Department that we have plenty of help coming. So have somebody else lay you another supply line. Okay, that is not a problem. So just consider that. You know, if you're thinking about taking a hydrant on a dead-end main, okay? So a couple of different ways we can get, you know, we can lay our lines to get supply from a hydrant. And again, this is firefighter 101 stuff, a forward lay. And I'm not going to show you the display here is we catch a hydrant and we lay in. And that's typically now what we do with 5-inch hose. You know, our hydrant guy hops off, wraps the hydrant with a 5-inch, you take off to the fire scene, a forward lay. Okay. Reverse lay is just the opposite. Okay. We used to do this back in the day when I first came on the department. I think when I came on, only maybe our squirt companies and the Quints had 5-inch. Okay, so all of our standard engine companies only had 3-inch. So we would drop a Y in the front yard with the first line and the second line, and then we would reverse lay out to a hydrant. Okay, so that is a reverse lay. We're laying from the scene to the hydrant. Pretty standard stuff there, okay? Now we may do this, and we can do this. We do this quite a bit as well. First pumper gets on the scene, they start laying lines off. They call for a supply line, and either that second pumper either pulls past that first pumper and hooks in and lays out to a hydrant, or backs down to them, and then again it's a reverse lay out to a hydrant. Pretty common for us to do that. Not a big deal in getting that task accomplished. Okay. So after the connections to the hydrant are made, the driver operator must take action before putting the pump into service. Okay, again, close that tank to pump valve. Okay, our apparatus now do have a clapper valve there in that line between the tank and the pump, so that water doesn't go back, doesn't flow back into the tank, pressurized water for that matter, and potentially damage our onboard tank. Okay, but go ahead and close that tank to pump valve. Okay, make sure you get a reading on your intake gauge. Know how much water you have when you start. Okay, and record that. At least get that in your mind. Okay, some of these things I've already talked about, but running your pump without water for a significant amount of time can cause overheating. Okay, for a few minutes it's okay. Okay, but if we're going several minutes, say we're having issues getting water, then pull that tank to pump line and get water circulating through that pump. You're probably already doing that already. If we have any issues with the hydrant, okay, then say we have a frozen hydrant or a hydrant that's inoperable, or it's not working, then may disengage that pump until we can get that solution fixed. And we may be asking someone else to lay it to a different hydrant, which is going to take time. Take a look at what's going on the scene. If you're operating a two-stage pump, which again most of our standard engine companies do have two-stage pumps. If you believe that you may need to pump over half of the capacity of water from your pump, then you may want to go ahead and initially set that transfer valve to volume before you start to increase the throttle. If you're supplying relay operations or if we're flowing large amounts of water, okay, we're going to be using the parallel setting. Make sure that we open all of our valves slowly. We're trying to prevent water hammer, okay, and damaging, things down the line from our discharges. Okay. Fill up your hose, make sure there's water gets to the hose all the way to the nozzle before you start to increase that throttle. All right, we talked about this already, okay? We do not let that intake gauge slip under 20 psi. Danger of cavitating the pump, okay? Danger of collapsing the supply line, danger of collapsing a water main. Okay. We've talked about this already. It's how to prevent overheating. We've hit that already several times. Okay. I think I snuck in here when Major Dalrymple was talking about this with you all. Okay, the differences between static and residual pressure determines how much more water the hydrant can supply. We'll briefly talk about percentage method and the first digit method. Okay. But make sure that you know how to do this. You've got a couple of lines off. Remember that you have to take a look at that intake gauge before you start supplying any kind of hand line or master stream, and see what your initial residual pressure is, what your initial static, quote unquote, static pressure is before you start moving water into your lines. All right. So these are like really, they're not too gross calculations that are going to be easy for you to use in the field. But what you need to make sure that you are aware of is, at all times, is how much more water can you throw? How many more lines can be laid off your apparatus? If you get to 20, you're done. Okay, that's easy. But you need to know, Mage walks up, hey, how many more lines can you lay? I need a blitz fire over here. I need you to supply, a truck over here. Do you have the capabilities of doing that? Okay, and with these calculations, you can have a general idea of what you can do. Okay, so that percentage method. Okay, first thing you need to do is calculate the drop in pressure as a percentage. So what you're going to do is you're going to take your static. Okay, so you say your static is 90. Okay, and then you lay one line and it drops it to 70. Okay, so we take 90 minus 70, that's 20. We multiply that by 100. Okay, and then we divide that by the static pressure. Okay, so static minus residual, multiply that by 100, gives you, and then you divide that by your initial static. Okay, so we said 90 minus 70, multiply that by 100. And then that's 2,000, divide that by 90, it's 22. Okay, Then, so if we had so that's your percentage. So if it's a 0 to 10% drop, okay, then you can lay 3 more additional lines. So say you're already flowing 250 GPMs. So now you can flow 750 more GPMs of water, essentially, okay? So if, I believe it's 10 to 20%, then you can lay 2 additional lines, and then over 20 or 25%, you may not be able to do any more, or may be able to delay 1 more line. Okay, so take a look in your book, and I didn't bring my book in here with me, and I should have. So my apologies for that. Okay, the first digit method is another method you can use. I never used this. If you got your book with you, take a look at page 349. So percentage decrease, let's back up here, okay? So talking about the percentage method, okay? We do our calculation. 0 to 10%, I said this one right, 3 times amount being delivered, okay? So you can lay up to 3 more lines of, say we already have 250 off, you can lay essentially 750 more GPMs worth of water, okay? If you have a drop of 11 to 15%, it's 2 times 16 to 25. You know, the same amount of water. Anything over 25, you're pretty much tapped out, okay? All right. First digit method, okay? So step 1, we find the difference in PSI between the static and residual, okay? And you can look at this example on page 349 as well of your book. Okay, so we'll just take a look at example 10.2 there in your book. So if you want to pause the video and go get your book, that'd be great. All right, so we find the difference. Okay, so say your static was 65 and then you drop to 58. So you've got a loss of 7 PSI. So then you take your first digit of the static pressure, which is at 6, and you multiply it by 1, and that gives you 6. Okay, 7 is not less than 6. But it's less than 12, so you can lay 2 more lines of 250 GPM. So we're starting with 250 GPMs. That's what you're initially flowing. Okay. So the rule is, if the PSI drop is equal to or less than the first digit of the static pressure multiplied by 1, then 3 additional lines are equal to flow. In our example, okay, it was 7, which was greater than 6. So in our example, PSI drop was equal to or less than the first digit of the static multiplied by 2. Okay, we could lay 2 additional lines. And if it's multiplied by 3, okay, if the PSI drop is equal to or less than the first digit of the static pressure multiplied by 3, then 1 additional line, okay? I never liked this method. You can try it and use it if you'd like. I personally liked the percentage method. It was quick and easy for me on the fire ground, and that's what I used. You know, just to be able to give the incident commander a general idea of how much more water I can throw out of my pumper. Okay. Shutting down the hydrant, make sure we do it slowly, just like we do with all of our valves, just like we do with all of our nozzles, so that we prevent water hammer. Okay. Okay. So, operating from static supply source when we are drafting. As I said earlier, typically Colonel Delaney has his class and he covers all of this material and does a great job at it. Again, this year I don't know if that's going to be able to happen, so I'm going to go over drafting with you out of the textbook. All right, so every fire pump should have the capability of doing this, and this is how we test our pumps when we draft. And again, as I said earlier, that plate on the side, you know, when we say that our pumps are rated for 15, you know, to pump 1500 GPM, okay, that's at a draft. Okay, so things we need, obviously the fire pump, use a hard intake hose, a hard suction is what we call it, and then obviously the static water source. And again, what we're doing is we are pulling air out of the fire pump itself, creating, dropping the pressure below atmospheric pressure so that water is now forced from that static water supply source into the fire pump. Okay? We do encounter some pressure losses when we do this. Diameter of the hose, length of the hose, the intake strainer, okay, as well as any adapters. Okay, and then the ability to overcome losses in pressure is limited to the atmospheric pressure at sea level. Okay, we are pretty much at sea level here, so we don't have to deal with this too much. But those cities that are at higher altitudes have to do some additional calculations in order to, to figure out, how well they're going to be able to draft from a static water source. Okay. Because the same atmospheric pressure of 14.7 must overcome elevation pressure as well as any friction loss that we talked about in the last slide. Then, as well as then if you increase the height of that lift, that's also going to decrease our total pump pressure. So with the pump moving water, the vacuum reading on the master intake gauge will provide an indication of remaining capacity of the pump. Okay, and these pumps can develop a vacuum of up to 22 inches of mercury. So we should be able to, you should be able to realize when your pump is beginning to cavitate, and some things are going to start happening. Your pressure gauge on your pump will start to fluctuate. Maybe air or hose streams start to kind of pulsate or start to jump around as you're starting to move air pockets through the hose lines. The pump may sound like there's gravel passing through it, and what's happening there is air bubbles are getting into the pump itself, and then those air bubbles, once they are put under pressure in the pump, they collapse, and makes it sound like gravel passing through your pump. Okay, and then you also have, you try to increase your throttle, and you're not getting any more pressure. So now you're overwhelming your supply. Okay, these are all indicators of cavitation. All right, so if you ever have to do, drafting, first thing you need to do is establish your site. Okay, some things you need to look at. How big is it? How much water is at your site? Obviously, the river we pretty much have unlimited amount of water out of the river. Okay, need to make sure that we can get our strainer to an appropriate depth. We need to have at least 24 inches of water all the way around that strainer in order for us to to pull a good draft. Okay, water temperature also has an effect on drafting. Type of water needs to be considered as well. Most water sources that static water sources we're going to be pulling water out of to draft, it's going to be non-potable. Okay, so this water is going to have dirt and sediment and other things within it that can potentially cause damage to the pump. So after this operation happens, the pump needs to be back flushed. Okay, it needs to be cleaned out, get rid of all that grime and debris that is in there, okay, from that water that we've been pumping through. Okay, how easy is it for us to get to the site to draft? Remember that if we have to, the more lift, the further we have to lift water out from our source, then that decreases our pump capacity. Okay. Okay, so once we've got our site, then we move the apparatus into position. Okay, we get our intake hose there where it's going to be deployed, set our parking brake, chock the wheels, Okay, don't engage your pump until everything's been connected. This is going to take a few minutes, okay, because you're probably going to have to go around and make sure everything is sealed up nice and tight, okay, because any air leak is the #1 problem with drafting. So we need to make sure that our hoses are connected tightly, and then any discharges that we're not using, any intakes we're not using, we need to make sure that those are tightened down as well. We don't want any air leaks coming in through those avenues either. Okay. So kind of backing up a little bit, you're going to park your vehicle short of the final drafting spot. Make sure your gaskets on your intake hose, on your suction hose, they're clean. Okay, and then if you're using more than one line, you're having to put those together. Again, make sure those gaskets are clean. There's no gravel, any dirt or grime. Okay, so that we have a clean seal when we put those sections together. You may have to use a rubber mallet to tighten those connections. Okay, may need to use a rope on the end of that strainer. So when we put the pump into operation for 2-stage pumps, the transfer valve needs to be in volume. Okay. We're going to operate the priming control. Okay. Make sure again. Make sure the pump's airtight. Set our engine RPMs, as I said. Operate the primer control. As air is evacuated from the pump, the master intake gauge will register a vacuum. Okay. As the primer operates, the vacuum reading should increase as atmospheric pressure forces water into the intake hose. Okay. And then what you should see is you're going to see that hose that is hooked to your intake. It's going to start to drop as the weight of the water, pulls that down. Okay, so now you know that water is being forced into that intake as you see the hose drop as it begins to fill with water. Priming action should not be halted until all air has been removed and you see a steady stream of water being discharged onto the ground from that priming pump. Okay, so it shouldn't take any longer really than 10 to 15 seconds if you're lifting water at a greater height. If you're working 10 to 20 feet of lift, then it may take a little bit longer. But if you haven't gotten a prime within 30 to 45 seconds, then you need to stop and trace the problem. Okay, the most common problem, as I said earlier, for a pump, to have issues with drafting is air leaks. Okay. Okay, and you can have air leaks from an open drain, an open discharge. If your valves on your discharges or other intakes have corroded a little bit, then you have air leaking around that can cause issues. Your intake relief valve or the gaskets on the intake hose couplings itself. All can be sources of leaks, allowing air to get in and not allowing you to get a good draft. Okay, but let's just say we got everything working now. So after you successfully get the pump primed, okay, start to slowly increase your throttle. Okay, and then slowly open your discharge valves. Okay. Then if you start to get a drop in your discharge, and say it goes below about 50 psi, then pause. Okay, allow the drafting to kind of stabilize itself, and hopefully it does that. Your pressure starts to go back up, and you can start to slowly open your discharge valve even more. Okay. Most common problem is the air leak on the intake side of the pump. Okay. Another place where you can have air enter the pump is a whirlpool at the strainer. Okay. So, or you have air leakage due to defective pump packing, or Are there other areas that I've talked about already? Okay, but if you have that whirlpool around the pump, you know, they said use something, you know, like a ball to place over that whirlpool. Okay, but you're probably not going to have a ball, you know, like a beach ball or something to put over that. Okay, but that can cause a problem if you're trying to draft and you have that whirlpool start, and then it allows air to go into your pump. Okay. Okay, so if you start to have a gradual increase in the vacuum with no change in flow, so you haven't increased your throttle, but you start to notice that you know, vacuum is going up, maybe you start to hear the engine RPMs start to go up, it may indicate that a blockage is developing. Okay. In extreme cases, the pump may go into cavitation. Okay, so we need to try to attempt to clear that blockage if we can. The most common place is at the strainer. Okay, so get any debris or anything like that cleared away. And you may also have issues with the hose itself. Perhaps something has gotten past the strainer in your intake and now it's up against the strainer on the inside of the hose. Well, the entire operation is going to have to be shut down if that's your problem. Another area that may be a problem is maybe the inside liner of the intake hose itself is starting to peel away, okay, and starting to cause a blockage. Now, once you shut everything down, you may not be able to find that. That inner liner returns to its normal place within the hose, and you may not see that once you start to look down inside that intake hose. But that may also, just an inside liner starting to tear away, may lead to a blockage. Okay, so when you're shutting down the pumping operation, you slowly decrease your engine speed. Okay, turn your throttle down. Okay, take the pump out of gear. Go ahead and drain your pump, get all your connections. Okay, and then go ahead and operate that primer. If it's an oil primer, let oil run through it. And what's not listed up here is then, you know, and I've already said it once, after drafting, you need to do a really good, thorough flushing or back flushing of the pump. Okay. Okay. Moving on, sprinklers and standpipe support. Okay, sprinkler systems are designed to support a specified number of fire sprinklers based on the hazard being protected. Okay, sprinkler systems typically do have an automatic water supply. Okay, and then we can obviously augment that supply by pumping into the fire department connection. When you get assigned to an engine company, and you probably already know this as a firefighter, but one part of pre-incident planning is to know where all your fire department connections, where all your Siameses are within your district, and even within, be familiar with where they are in your second alarm. Okay. It is within our SOPs that the first engine is to take the Siamese. If for whatever reason that first engine cannot, then he is to radio to the second engine to take that Siamese. But we take Siameses every time we make one of these occupancies that has a sprinkler or a standpipe system in it. Okay. Always, always, always. Now, we don't necessarily have to hook hoses up to them every time we just make an alarm sounding, but once we find out that there is, or once we start to get an indication that there is actually a fire, then we need to be hooking in to these fire department connections, to these Siameses, and then laying out and establishing a positive water supply, okay, and start pumping into these systems to make sure that they're supported. Okay, the general guideline for fire department for a Siamese is 100 and 150 psi. Two types of standpipe systems. They may be wet or they may be dry. Okay. If it's a dry pipe system, then the water is going to come from the water supply that is on site, a stationary fire pump that'll also be there on site, and then we can augment that system as well. We can supply our own water. Okay, but there are also wet pipe systems. Probably not going to find too many of those around here. To be quite honest, I'm not real sure. All right, but I always support the Siamese, and they may or may not be adequately marked. For those of you all, and probably not anybody listening to this class, but Colonel Carroll told me way back in the day, he said those can be complete opposite. It may be marked for a standpipe and it actually supplies a sprinkler system, and vice versa. So don't always trust those. The best way that you're going to know what Siamese supplies what is through pre-incident planning, getting out and taking a look at these buildings. Okay. Okay, so pump discharge pressure is going to depend on the pressure loss or friction loss in the hose lay. Okay, friction loss on the hose on the fire floor, nozzle pressure, all these kind of things have to come into account. Now we've taken care of that for you already within the SOP, so that you know what you know you're supposed to be supplying to sprinkler systems, and what you're supposed to be supplying to standpipe systems. Okay. Some things you need to take into account when equipped with a pressure reducing valve. The elevation pressure must be based on total height of the standpipe or the zone being used. So if the pressure at a particular valve is less than that for which valve is well adjusted, it will result in inadequate pressure for an attack. Okay, so we may have to adjust that, and we have the capability to do that to adjust a PRV with that tool that we have in our high-rise kits. Okay, if you're not familiar with how to use this, we do go out and take a look at some of these. Go out and plan some of these buildings and take a look at pressure reducing valves and make sure that you know how to operate it using your tools within your high-rise kit. Some standpipe systems may require, I should say may, not may, require adaptation in order to be used. So say we roll up and we do have indications of fire, so we're going to take the Siamese, and you notice that one side of the Siamese is damaged. What can we do? Well, in that instance, we can use the other side of that Siamese and then put onto that Siamese our own Siamese, and now we're pumping two lines into that. If the entire Siamese, another situation is if the entire Siamese is damaged, okay, perhaps go into the first floor, and if we're supplying a standpipe system, then we'll use that first floor standpipe to charge the standpipe system. Okay, so a couple of options we have if we run into issues with supplying some of these systems. Okay, when you're applying these, make sure that you are in volume position. Okay, when you're doing this. Okay, so just a general overview of supplying sprinkler and standpipe systems. Last thing we're going to talk about is some troubleshooting. Okay, just in general with your pumping operations. And again, this was something that we typically go outside with this class, and we'll look at how to manually override your pumps, how to we'll run a broken supply line drill. Okay, unfortunately, like I said, with what's going on right now, we can't do that. So, But some troubleshooting things, just be ready, okay? Know your apparatus. You not only need to know what to do when everything's going right, but you need to know what to do when things go wrong. If you have any issues in pumping, first thing you need to do is to notify the crew on the inside or crews on the inside, okay? That you're having issues, whatever it may be, okay? Make sure that they get out safely and try to provide water to them until they get out safely, okay? So notify the officer and or incident command, okay? And then trace the problem back to its source and attempt to troubleshoot, okay? Use a logical process to trace the problem back, okay? And a lot of times, the best advice is just to start over, okay? If the problem is not immediately visible to you, start over. Go all the way back to the beginning, okay? And make sure that the pump is in the proper position inside your cab, okay? And then start to work the problem forward. Okay, so that is the end of this chapter, okay? You guys continue to be safe out there, and hopefully we'll see you soon back down here. Thanks.